Hey guys, this is AK and I'm back with another JE question and a really neat solution. So the question is, it's question number 10 of Cody of JE Main 2016. The question is, a particle performs simple harmonic motion with amplitude A. Its speed is trebled at the instant that it is at a distance 2a by 3 from equilibrium position. The new amplitude of the motion is. Before I describe to you the question, let's go over a few terms used in the question. Simple harmonic motion. An object whose position varies as xt is equal to x naught plus a cos omega t plus phi. So let's say there is a particle right here and it's exhibiting SHM, which means it keeps oscillating. It goes from here to here and then here to here like this, right? So this part is called amplitude. This is also amplitude. It's the maximum displacement if this is the equilibrium, right? And then it should follow this equation, and x-axis is time and y-axis is x naught plus a cos omega t plus phi. If x naught is 0, then I can just remove this and all I will be left with is a cos omega t plus phi. So a cos omega t plus phi will be represented on this axis, where a is amplitude, omega is angular velocity, t is time, phi is phase constant. If you really want to understand how we get this expression, then check the description. I've made another video on how this expression, how you can understand this expression, and that will really help you understand SHM. But right now I'm not going to explain this. I'm just going to use this expression. And then if this is displacement, what is velocity? We know that velocity is differential of displacement. It just change how distance changes over period of time, and then you can write d. D is just a very small quantity. It's not going to make any difference. So velocity is differential of displacement, right? So what's the differential of displacement? Differential of displacement is differential of a cos omega t plus phi. A is a constant, so I'll write a. Differential of cos omega t plus phi is like cos theta. Differential of cos theta is negative sine theta, so I'll write negative sine omega t plus phi. And then what is the differential of omega t? We are differentiating with respect to t, so omega t will be omega, so negative omega a sine omega t plus phi. Differential of phi is just 0. I don't need to write it. So velocity is this. So I'm going to use an expression which you may know, which you may have heard of. V is equal to omega square root of a square minus x square to solve this question. But I will discuss in brief how you get this expression, so you may know where this expression comes from. If you were to square displacement plus v squared over omega squared, what would you get? You'll get x squared is a square cos square omega t plus phi, right, from here, and then a square sine square omega t for v square over omega square. This is v. If you were to square it, you will get omega square a square sine square omega t plus phi over omega square. Omega square will cancel and you'll be left with this. So I've taken a square as common. I'm saving time. So a square cos square omega t plus a square sine square omega t plus phi. And we know that this is 1, sine square theta plus cos square theta is 1. So I'm just going to write 1 and I'll be left with a squared. Now I'm going to send x square over to the other side and I'll get v square over omega square is, what was left was a square minus x squared. And then v square is equal to a square minus x square omega squared. And then I'm going to take square root to get v is equal to omega multiplied by square root of a square minus x square. So that's just the maths part. Good to know where it came from. Let's solve the question. So the question says there's a particle and it is exhibiting SHM, right? So V is equal to, what happens is that at 2a by 3 distance, so let's say this is its amplitude, this is equilibrium, this is its amplitude, and when it is at this position 2 by 3 of a, that's what the question says, right? 2 by 3, let's say approximately it's here. What's done to it? Its speed is trebled, which means its speed is made 3 times what it is right now. So if you give it a push, let's say you give it a push to make its speed 3 times, it's gonna overshoot its amplitude, right? And that's what they are asking. What is the new amplitude? So what is this new distance? How can we find this? If you were to treble the speed at this point, what would be its new amplitude? So let's use the formula. Let's see what its original velocity is, which will be omega minus, which will be v is equal to omega multiplied by square root of its original amplitude minus 2a by 3 is its displacement from the origin, 2a by 3 whole squared. If you solve this, you will get root 5 by 3 times a omega. If you don't get it, I'll explain it to you, comment below, but I think it's fairly simple, you can do it. Now if I triple the velocity, let my new velocity be v dash, okay, or v prime. And what happens when I triple the velocity? It becomes 3v, right? So I'll multiply 3 times on the both side, on both the sides, and I'll cancel these 3's out. What will I be left with? Root 5 a omega, right? So that will be the new velocity. So I'm gonna write v prime is equal to root 5 times a omega, right? So if this is the new velocity, it's equal to omega times square root of a squared minus x squared, right? And what is a squared? It's the new amplitude. So I'm to differentiate it from my original a, I'm gonna write a prime, okay? So omega times square root of a prime minus x squared. What is x squared? I can express x, which is displacement, as 2a by 3 still, because 2a by 3 is its distance, so that's not gonna change, where a is the original amplitude. All right, so let me equate these two. Root 5 a omega, okay, this right here is equal to this expression right here, okay? So omega times square root of new amplitude squared minus 2a by 3 whole squared is equal to root 5 a omega. And then let me square these two sides to get rid of square roots. What I'll be left with? Omega squared, right? Omega squared is omega squared, and then whatever it was in square root, a squared, a amplitude squared, new amplitude, minus 4 by 9 amplitude squared, okay, is equal to root 5 squared is 5, and then a squared omega squared, right? So you can see that in the options you are supposed to express the new amplitude in terms of old amplitude, and we're getting there, so we are on the right track, right? So new amplitude squared is, what I'm gonna do is, this is 5a squared, right? Omega squared cancel out, and then what you are left with is negative 4 by 9 a squared. I'm gonna send it over to here. You'll get 4 plus 4 by 9 a squared, right? And then what is this? You have to take the LCM. 5 9s are 45, 45 plus 4, 49, 49 over 9 a squared, right? And then you can cancel this out. So if you cancel this out, you will get, I'm sorry, this you cannot cancel, but what's a amplitude, new amplitude squared is this much, right? So a amplitude will be square root of this quantity, which is square root of 49 is 7, square root of 9 is 3, and then a squared is just a. So the new amplitude is 7 by 3 times a, which is the third option right here. So this is how you solve the question. And if you want to know details of SHM, how an SHM can be represented in a circle, do watch the video in the description. I hope you like this solution. If you like, please comment, like, and subscribe to my channel. Thank you for watching this video.